Hey, hi everyone, welcome back to my YouTube channel. My name is Sunny and I'm back with another exciting and important video. In this video guys, we're gonna discuss about the instruction fine-tuning. As you know, I started with the end-to-end LLM fine-tuning playlist where I uploaded 14th video so far. In the previous video, I discussed how you can train your pre-trained LLM model on your domain-specific data. If I'm saying domain-specific data, means the data could be available in any format and the data would be available as a plain text. Now, in this video, we'll see if you have instruction-based data, then how you can fine-tune your LLM model. So we're gonna take same model which we have already trained in the previous class. On top of the same model, I will perform the instruction based fine tuning. So this video is going to be very important. Now guys, if you haven't seen with my YouTube channel, please go and check. There you will find out a video with respect to each and every concept of the AI, of the generative AI. So if you are willing to learn generative AI, then you can refer to my YouTube channel. And after watching the content only, you can make a decision whether I have to subscribe or not. Now guys, if you will go in the playlist section, you will get each and every playlist, whether it's a RAG, fine tuning, LangChain, LangGraph, advanced RAG, multimodal RAG, everything you will get, right? If you want to start your generative AI journey, then you can watch this particular series, this particular playlist where I kept all the video in a sequence. Okay. Now guys, let me discuss what all point we are going to discuss in this particular video. So the first is what is the instruction fine-tuning, then how the data looks like in the instruction fine-tuning. Then we'll see why it is called the supervised fine-tuning, as I discussed in the previous class that this is instruction fine-tuning comes under the supervised fine-tuning only. Then I will come to the practical, right? So this each and every point I will discuss throughout this video, and yes, at the end you will learn how you can fine-tune your LLM model on the instruction based data. Now guys, without wasting our time, let's start with the video. Let's understand the theory first and then I will come to the practical guys. So guys, before starting with the instruction fine-tuning, let's take a recap of some previous points. So the first thing is, what is the meaning of the fine-tuning and why we do it? So here is a definition. Fine-tuning means retraining an already trained model on your own specific data set. So guys, here if I'm talking about the model, right? So the model is nothing, it's a LLM model. Now this LLM model, it is based on the transformer architecture, as you know. So let me write over here transformer. So this transformer is nothing. It is a research of the Google which was published in 2018 itself. Okay, it was a sequence to sequence architecture where we were having two main things. One was the encoder and the second was the decoder. So the GPT model, right? The GPT model actually, it was built on top of the decoder part of the transformer. So if you want to understand the LLM, then before coming to any LLM architecture, understand about the transformer, okay, and then jump to the LLM. Now here I'm saying LLM, right? So we are going to be retrain already trained LLM, and if I'm going to be talking about the training, right? So what we're gonna train here? So we're gonna train weights and biases. Okay, so weights and biases. Now this weights and biases, where you will get this weights and biases inside this transformer architecture. So we have attention, right? We have attention layer inside the transformer plus neural network. Okay, so this transformer, one single block of the transformer, it is a combination of the attention layer as well as the neural network, right? So there we will get the weight and biases, and yes, if we are going to be train our model, means we are going to adjust the value of this weights and biases based on that loss function and the optimizer. And if we are going to be again retrain it, in that case also we are going to be adjust the value of the weight and biases according to your data. Okay, and that's a whole sort of a meaning of the training or retraining, right? So I think you understood about it, and if you don't know about this basics and all, then you can follow my previous video. There I already discuss about this thing in a very detail along with the practical, right? Now if we're talking about the LLM training process, so in the LLM training process, the 3 stage plays a very important role. The first step is called the unsupervised pre-training, or it is also called the self-supervised training, which we are doing on the common crawl data set. So generally we consider the internet data over here, the entire internet data. Okay, then the second thing is called the supervised fine-tuning. Now inside the supervised fine-tuning, I discuss two things. The first first behalf on the parameter, okay, and the second based on the data, right? I will again give you that recap. The third was the preference based alignment or preference based training. Now here whatever output we are going to be generate, right, from the AI, from the model. Okay, so based on that particular output, based on the feedback of the user, again we are going to retrain our model, right? So that comes under this preference based alignment. So here we have very popular algorithm that is called a PPO, right? It is a reinforcement learning based technique. Now apart from the PPO, we have one more state of art technique that is called DPO, okay, direct preference optimization. So we'll discuss that in our next video, okay, and even I will show you the mathematics and all in my upcoming videos. So guys, here my main focus onto this supervised fine tuning. Now let's take a recap of it. So as I told you, if we're talking about the supervised fine tuning, so we can divide into two sections, right? So one basically it is based on the parameter. Already I discussed this thing in my previous video. I'm just giving the recap of it. And the second behalf on the data, right? Now if we're talking about the parameter wise, so parameter wise, the first one is called the full fine tuning, okay, full fine tuning, and the second is called partial fine tuning. Okay, partial fine tuning. Full fine tuning means we are going to retrain all the parameters, okay, inside the model. Whatever parameters we have, we are going to train all the parameters. So generally we don't follow this particular technique. So we always go with the partial fine tuning, means we take subset of the parameter over here, okay, subset of the parameter. Now we're talking about the partial fine tuning. So we have two techniques over here. The first technique is called the old technique, okay, old technique. Now here's in the old technique, what we are doing, we are going to be freeze, okay, we are going to be freeze some layer, okay, and we are going to be train some layer, right, some layers, okay. But guys, in terms of LLM, we don't follow this particular technique, right? Instead of that, we have second technique that is called PEFT based technique, parameter efficient fine tuning technique. And in that, Lora is a very famous technique, right? So Lora is very famous technique. Now apart from the Lora, I discuss couple of more variants of the Lora, couple of more techniques. So if you want to understand that, you can watch out my previous video. There I discuss in a very detail, okay. So here you understood, we are going to perform the partial fine tuning, and in that we're going to discuss about the PEFT, and Lora is one of the way to follow the PEFT, okay, to perform the parameter efficient fine tuning. Now the second is based on the data. So if we're talking about the data, guys, so data we could have, okay, let me take a different color over here. So data basically is available, right, in a non-instructional format, right, in a non-instruction format, or this is also called the plain text. Now this plain text, it would be available in any sort of a document, okay, in any sort of a document. Now this document could be the PDF document, this document could be the PPT document, this document could be the docx, right, this document could be anything, right, wherever basically we'll find out the plain text, that comes under this non-instructional category. The second data, the second type of data is called the instruction data, okay, instruction data. In instruction data, actually how it looks like, I will show you that. So instruction data, actually there we will be having input column, as well as the output column. Okay, as well as the output column. So guys, this supervised fine-tuning, this specific term, actually it is being used in terms of this context, in terms of this instruction data, okay, where actually we have an input and we have an output. If you will think about the machine learning, right? So in the machine learning, guys, we have supervised machine learning, and in the supervised machine learning, what kind of data we have? The data where we have an output column. Okay, so in whatever data we have an output column, and we are feeding that data to the algorithm, any algorithm, it's a decision tree, XGBoost or SVM, right? And behalf on that labels the Y column if my model is learning. So that is what? That is a supervised learning. In a same way, guys, this SFT actually is, okay, so because of this instruction fine tuning only, it is called the SFT, means we have an input column and the output column. So then what is this a non-instructional data? Okay, means it does not comes under the supervised fine tuning. I would say no, not directly, because this instruction fine tuning technique, right, it is only called because of that only we call it the supervised fine tuning. Why? Because we have a labeled over here, okay, the output column, right? Now guys, over here what we are going to be do, see, now one more thing, let me tell you over here. If we are talking about the LLMs, right, so whatever technique we are discussing, right, let's say in whatever stage we are, so let's say we are at first stage, at this particular stage, unsupervised pre-training or self-supervised learning, there also we are going to predict the next token. Okay, now if we are at this particular stage, SFT, supervised fine tuning, at this stage also we are going to predict the next token. We'll format our data in such a way that model will predict the next token only, right? And in the preference based alignment, or in this particular like technique, again we are going to predict the next token. So in whatever way we have a data, right, it doesn't matter. Let's say we have a data, the entire internet data without label, in that case also we'll arrange a data in such a way that's going to predict the next token. If we have a data in the instruction in the output format, in that case also we are going to predict the next token. We'll format our data in such a way, we'll predict the next token. If we have a preference based alignment means we have generated output as well as the feedback regarding that, in that case also we'll format our data in such a way that model is going to predict the next token. Okay, so as it is a language modeling, and model will always predict the next token in whatever way we have a data, okay, at whatever stage we are going to be perform the training, right? So I hope guys this thing is clear. This is the fundamental which I already discussed. Now let me talk couple of more points. So here I have written why it is called the supervised fine tuning. So in pre-training, that is a first stage, right? There we are doing a training on top of the entire internet data, where actually that particular stage is also called the self-supervised learning, means the label will be the next token itself inside the sentence. So there actually what we are doing, so in the pre-training data, model predict the next token from the natural text itself, right? But if we're talking about the instruction fine-tuning, there also model is going to predict the next text, but we have curated data in such a way that we will be having the target column. Okay, so in instruction fine-tuning, model predicts the next token only, but from the human curated target answer. I will show you the example, and because of that it is called the supervised fine-tuning, means this instruction fine-tuning is only called the supervised fine-tuning. So guys, over here I can give you the quick recap. If we're talking about the LLM training process, so we have three stages: unsupervised, pre-training, or self-supervised. There's a first stage where we are going to be create our raw model. Second is called the supervised fine-tuning, where we have already seen about the partial fine-tuning, that is called PAFT, and that is a Lora. Okay, this is based on the parameter, right? How many parameter we are going to be select while we are going to be train the model. Now data wise, how we are going to prepare the data while training a model. So we have two ways. First is the non-instruction, where we just have plain text, right? And second is the instruction based data. Now because of this instruction based data, we end up with this specific name that is called the supervised fine tuning. Okay, but guys, if we just have plain text, then ideally we should not say it's a supervised fine tuning, means here we will say we are just going to be fine tune our model, okay, on top of our domain specific data. Okay, now I hope everything is clear. So let's do one thing. Let's take some example, and then after that we'll start with the practical, guys. Now guys, let's revise the differences between the non-instruction and the instruction fine-tuning, and after that I will let you know why this instruction fine-tuning is required, and then we'll move to the practical. So non-instruction fine-tuning, first let's discuss about this one. Non-instruction fine-tuning, so fine-tuning on a plain text means teaching the model your domain language. Now what's the purpose of it? So the purpose is to help a model to learn the language, tone and the terminology is specific to your domain. Okay, so let's say if you have this type of data, the plain text which is available in any sort of a document. So on top of this data, we are going to be retrain, or we are going to be fine-tune our LLM model. Now in which format we are passing our data to the model. So the data you will get at the end, you will get in this particular format, means we are going to put the next token. Okay, so the next token will be in my output column. So let's say this is my sentence. Okay, so this is the next token regarding it. Now this is my sentence. Now here is the next token. Now this is my complete sentence, and this is the token, right? We already understood in the previous video. So let me give you one more concept over here. Let's say there is one company. Let's say there is Meta. Okay, Meta has trained one model. The model name is Llama 4.2, something like that. Now you want to be use this particular model inside your organization. Okay, so you belong to, let's say, Pharma. Okay, Pharma. Now in your company, in your organization, you want to be use this particular model. So what you will do? So you will directly take a model and start using it? No, this is not a right thing, because this model does not know the pharma specific term, right? This model does not know about the pharma specific term, so it will hallucinate. So what you will do here, you will fine tune. You will go with the fine tune. Now here for the fine tuning, directly you will fine tune on the instruction data set, means directly you will fine tune on the input and output data set. You can do it. You can teach your model. Okay, you can teach your model if this is the input, then regarding that what will be the output. This is only called the instruction tuning. But guys, this is not a good practice. Okay, directly to teach your model on a input and output, it's not a good practice, right? So in between, what you can do, you can take your data, company specific data, okay, from wherever you have collected that. So you will have a big corpus, okay, for your company data. Then first perform the non-instructional fine-tuning. Now with this particular tuning, your model will understand your data, right? It will understand the specific vocabulary. It will understand the terminology. It will understand the technicality of your data. Means overall, it will deep dive into your data, right? And after performing this particular step, the non-instructional fine-tuning, then come to this stage where you are teaching to your model the more structured output based on the given input. I hope this thing is making sense. So that's why guys, this step, okay, most of the YouTube video will not teach you this thing. This particular stage is very much important, and I already covered in my previous video. You can go and check. Now coming to the instruction fine-tuning. So in the instruction fine-tuning, you will get a data, right, in the form of instruction, in the form of input. Okay, so let's take an example of it. So first of all, let's discuss the purpose. So what is the purpose of it? To train the model to understand instruction and generate well structure and the relevant answer. Okay, so to generate a structure and the relevant answer based on the given instruction. So you will find out a data in this particular way, in this particular format, where you will be having the instruction, you will be having the input regarding the corresponding input and the output. So instruction, summarize the following paragraph. Now this is the input regarding it. Okay, and we are going to be summarize. So this is my summarization. Here is my summarize output. So after giving this particular input, we should get this kind of output. Okay, so this is my instruction. Now without input also you will find out some sort of a rows. So let's say you have an instruction list application of AI in pharmaceutical research, means here you are giving input and then this is the corresponding output. Okay, now here one more example. So explain a mechanism of the Metformin. Now we don't have any sort of input. Now here is my output. Okay, so in this way also you will get a data. So this data set format was followed in the Alpaca, right? So if you will check with this Alpaca, right? So this is one of the data set which was prepared by the researcher. I will show you the research paper and the Hugging Face dataset and all everything. I think I showed in my previous video. You can check over there, right? So in this format only the dataset have been prepared. But apart from this one, you will find out dataset in some different format also. So this is the one format: instruction, input, and response. As I told you, this is the Alpaca, right? Apart from that, you will get the instruction. This input could be the context and this response could be the answer. In this format also, you can also prepare the data. You can directly prepare the question answer data as a user and the assistant. Okay, in user column you can give your questions, and in assistant you can write your answer. You can give the you can prepare the data in this format also: system, user, and assistant. Okay, this is also a way to prepare data for the instruction fine tuning. Otherwise, context and response. See, here I kept one example for the context and the response, guys. So I hope this thing is clear in which format actually you will get a data for the instruction fine tuning. Now here is one more point I written. I missed this part, so you can read it out. If instruction uses as extra text, means if you have a instruction and the input, right? So in that case, mostly you will find out we are saying to the model, do the summarization, translation, rewrite. You can go ahead with this particular example. So here we are giving an instruction to our model with respect to this input, and then we are generating this output. Now here you can see the second line. If instruction is a self-contained, okay, if instruction is having the self-contained context or dialogue style or conversational data, then you can keep input empty, means this thing, right? I just written it as an extra note, and I think you are able to get it. What I'm trying to say here means, if we have an instruction, then we are giving an instruction with respect to this corresponding input. If we don't have any sort of input, means in the instruction only we are keeping some context, okay, some question, and regarding that here is the output. As simple as that. So I hope guys you understood this entire thing. Now the biggest question, how you are going to be generate this instruction data, because in every company, let's say if I'm taking example of any XYZ company, any ABC company, or any YXZ company, everywhere you will not find out this kind of data. Okay, sorry, not this kind of data, means instruction data. So what is a way of preparing the data, the instruction data? Okay, the first way, see here, now the question is how to prepare the data for the instruction fine tuning. Means in your company, let's say the data is available in the PDF, right? So this is the biggest hurdle. You have trained, you have done the non-instructional fine tuning, but how you will teach your model to generate the structure answer, right? So for this one, for generating a structure answer, you will have to prepare that kind of data, input and output. How you will do that, right? So here is a way. First, you can do it manually. You can write your own question, means you can only create your question and answer, right? But you cannot do it for very huge scale. Here the accuracy would be very, very high, but this could not be ideal. If you have very less data or maybe mediocre data, in that case, maybe you can do it, but there's not an ideal situation, right? The second thing is SME. So again, it's a manual way only. Expert is doing that. You are hiring some intern and all for doing this specific thing, or some SME just do it for doing this thing, or like so many people are working in parallel, then this process could be faster. But again, this human annotation is not an ideal thing for the bigger data set. So the last thing is the LLM synthetic data. Means here to the LLM only you can give some instruction. Not instruction, I would say instruction will be the like confusing. Here to LLM only you can provide some prompt, okay, some guides, right, to the GPT kind of to GPT model, to Cloud model, right? So those model only can prepare your instruction data set. Means let's say you have a plain text. This text you are feeding to your GPT model and you are saying, can you prepare some question and answer from this particular text? GPT model will do it for you. So this is the one of the way, and company is following this specific way, like they can generate a LLM synthetic data. Now guys, the next thing is, let's say if we have a data in this way, okay, but how the LLM will look into the data, okay, means it will be like this: instruction, then input, and then output, right? Separate one, like we are having in the machine learning. As I told you, this is a supervised learning, right? Supervised. Why it is a supervised? Because we have a human curated output over here. But actually, this is the language modeling. Language modeling means we are doing a next token prediction. Okay. So at the end, we'll have to format this data in such a way that so that LLM can perform the next token prediction, right? So let's say this is my data, instruction, input, and output. So here you will be formatting your data in this way. So here is the instruction, then this is the input, right? And here you can see the response, guys. Getting my point? So here, guys, the native, right? The native role or the native behavior of the LLM to predict the next token only, right? So because it is a language modeling, the native behavior of the LLM to perform the next token prediction. So for sure, in whatever way we have a data, at the end we'll have to prepare a data in such a way that model can perform the next token prediction. So let's say we have instruction, input, and output. So for sure this is a supervised data because we have a label over here, but at the end we'll feed the model in this specific format. Okay, means input and instruction what will be there along with the responses, and model is going to be learned from this specific responses. I hope this is getting clear. Now let's see why this kind of tuning is required, why instruction tuning is required. Then we'll move to the practical. Now guys, let's understand why this instruction fine-tuning is required. Let's take a look onto it. So here I written a base LLM like Llama, Falcon, GPT, or any LLM model. It only knows how to predict the next token. Okay, so I written over here. This means it understands the pattern only, pattern of the data, and based on the pattern only, it's going to be decide what will come next. Okay, next token or sentence prediction. So here is the example. You can see the example. We have an input. Metformin is used for. So this will complete the text. The output will be the treatment of type 2 diabetes mellitus. Okay, this is fine. But guys, if we are giving this kind of prompt to the model, like explain this, summarize this, write this, translate it, or what it is, right? So in this case, the model is going to be fail, means model will not generate the appropriate answer in a model will not generate a answer in a natural language, like how we human are talking, right? So that's why guys, the instruction fine-tuning is required, and that was the like successful mantra behind the ChatGPT, right? How ChatGPT is giving the human curated answer, right? Human compatible answer because of this instruction fine-tuning. So let's say here is example. If you will ask the model, write 3 points on Metformin mechanism, so it might respond with something like this: write 3 points on Metformin mechanism is request. Means it will just predict the next token instead of giving the 3 bullet point or 3 points. Okay, now because of this, right, because if we want a instruction like a structure answer, or if we want a relevant answer, right, if we want an answer in a human curated form, for that only this instruction fine-tuning will be required. So here I written So the conclusion is to teach the model the meaning and purpose of different prompts. Okay, so for the different prompts, we perform this instruction fine tuning. Now in the instruction fine tuning, how the data will look like, as you know, right? And what will be the result? So result could be anything, whatever user is asking. So I hope you understood why this instruction fine tuning is required. Now, without wasting a time, let's start with the practical. Now guys, let's start with the practical of the instruction fine tuning. So in this ipynb file, I kept the entire code. Now in the previous video, I have shown you the practical of the non-instruction fine tuning. This entire code is already available on my YouTube channel. Please go and check the description of the previous video. You will get the link of this GitHub. Okay. Now in the previous video guys, I have used this particular data metformin.pdf. So inside this PDF, I'm just having one single page. Okay, but in the real time, the data could be very huge. Now guys, this was the non-instructional data, means the plain text. So I trained my model on top of this data. But in this video, we required the instruction data set, means we required the question, means the instruction and the corresponding responses. Okay, so I already created a data. I will show you in some time, right? Now over here guys, I'm going to use the same model which I trained in the previous video. Okay, so what is my ideology over here? Let me talk about that what I want to teach you. So let's say we have one pre-trained model. Okay, so we took the Llama model. This is from the Meta. Now I got a problem statement that okay, I have to fine tune this model for some pharma data, right? So I downloaded this model, this pre-trained model, which was this one, Tiny Llama 1.1 intermediate step 1431K3T. Okay, this model is a quite small, that's why I have used it. Otherwise you can use any sort of a model if you have a good infrastructure. Now guys, I took a pre-trained model, I trained it. Okay, I performed the non-instruction fine tuning on plain text. Okay, now why did I perform it? So that I can teach my model the specific terminology. Okay, I can make my model basically this pharma ready. Now I will teach my model to follow the instruction. Okay, now what I'll do, I will do the instruction fine tuning, okay, on instruction data set. So guys, I have a data set, the plain text and all. I taught my model basically the language, the tone and all, everything. Now I will take this instruction data set and I will teach my model how to respond with respect to the different questions. Okay, then in the next video I will discuss the preference alignment. So based on the user preference, okay, which response needs to be picked up. So the next video I will upload with respect to this preference alignment. So as of now we are over here. I hope you got it. So guys, whenever so when I was training this model, right, so I already saved this model. So let me show you. So I already saved this model under this directory. You can check with my previous video. Okay, I shown you over there. And what I did after that, I zipped the model. Okay, and I downloaded that so that I can use it anytime. So here what I'm doing, I'm going to be basically unzip this file, this tiny LoRa.zip file, and then I will load my previously trained model. So first of all, let me load the tokenizer. I'm going to be execute this one. This is perfect. I think you are able to understand it clearly. Now let me run this. Okay, let me import all the necessary libraries. So here I think you are already familiar with all these libraries. Okay, now what I'm doing guys, I'm going to be load the tokenizer. Tokenizer is very much required to perform the tokens, to get a tokens, okay, and the token ID with respect to the data. Now here what I'm doing guys, I'm going to be unzip the model. See, here is my model, this one. After unzipping it, I will get like this one. This is my folder. I already run it, that's why I'm getting it. But if you are running it first time, you will means if you have this zip and basically if you will run it, then you will only get this checkpoint, right? So I'm going to be execute it and see, after unzipping it, I'm getting this checkpoint -5. Okay, Now guys, I got my model. Now let me load my model. So this is my model path. So what I'm doing, I'm passing it to this particular method, auto model for causal LM from pre-train, and here I'm passing my model path. Okay, and device map is equal to auto. So I got my non-instructional model, right? Now what I can do, guys, after loading this model, so it might take some time if you are doing it first time. Now I am giving my prompt. This is my prompt: clinical trials demonstrate that whatever, right? Now what it will do, it will try to predict the future tokens. Okay, so it is not any instruction, it is not a like a specific question, it's just a simple sentence. Okay, and it will try to complete this sentence. So here's my prompt. First I will tokenize it, then I will pass my input. Okay, and these are the other parameter. I will discuss this parameter, it's very easy to understand. So how many max token would be there in the output. Temperature means whether my output will be creative or not. Okay, top P is also belonging to the same thing, right? So this parameter will discuss in the upcoming session. I will discuss some more theoretical, more like a mathematical point. Okay, so there we can talk about it, or else we'll discuss any sort of a API, right? Open API, cloud API, and there also basically you will get this parameter, and for sure we can discuss. Now here I got the output. See, let me show you the output. So first we'll decode it, and after the decode, see, you will get the output. See, critical try demonstrate that combine atorvastatin with ezetimibe is a safe and effective to treatment of the like cholesterol. Okay, so like these are some pharma related terms, some disease specific term, even I'm not familiar with it. So see, it is able to generate the response, right? Now what I'll do, guys, so here first of all let me show you how the instruction data set look like, and then I will take the same model, this non-instructional model, and then we'll try to perform the fine tuning. Okay, so to just give you the demonstration, see what I did, I'm loading this pre-built dataset, inbuilt dataset from the Hugging Face itself. It is already available inside this repository, AMOD repository, and the dataset name is this mental health counseling conversation, right? So once I load it, guys, see, I'll get the data inside this variable, dataset variable. Okay, now here if I can show you the data, see this data. Okay, is data set. So let me write over here data set. So I got the data set. Now inside the data set I just have two columns, context and the responses. Okay, and how many rows we have? We have 3, 5, 1, 2 rows, right? Now I already downloaded this data set just to showcase you. I downloaded in both format. In any format basically you can keep the data. So this is a CSV format. Let me show you the CSV first. Okay, so inside this CSV you will get the context and the responses, right? So as I told you, this instruction fine-tuning data set, it could be available in any sort of a format. Even I given you the example over here. So instruction input response, instruction context answer, user assistant, system user assistant, context and response. So inside this data set, which is already available over the Hugging Face. Okay, so inside this data set basically you will get two columns. One is the context and second is the responses. Now see, the same data set basically I saved in the JSON format also. So yes, for sure you can keep it in both a format, right? Now what I'm doing here, so I loaded the data set. Now I'm going to be formatted. So here basically I will be having my question, means this context is nothing, it is a question. This response is nothing, it is an answer. Right now I'm going to be combine both, and after that I'm keeping inside this text column. So let me execute it. So after executing it, guys, see what I'm doing, I'm mapping my entire dataset.map. Okay, and here I'm mapping my function. My function name is this format row. Okay, so once I'll do it, guys, I'll be getting my formatted dataset. Let me show you. So here is my context, this is my responses, and this is my text. Okay, so see over here. So instruction, what is the instruction? INST. Okay, it is a instruction. So this is the instruction. I am going through this, that, right? And then with respect to this instruction, here you can see the final responses. Okay, so what I did, guys, I formatted my dataset. Means either I can keep this context and response, okay, or I can keep it like this, instruction and this slash instruction. So instruction is only representing the question, and this slash instruction is representing to the answer, right? Now over here, instead of writing this instruction and question, I can simply write this context, means hash context, okay, or like this context and then response, right? Let me show you how I can keep it. So you can keep like this. So let's say here is your context and this is your response. Now whatever text column you will get, so whatever text column you will get like this. Means instead of the instruction you will be having the context, and then instead of the slash instruction you will be having the responses. Okay, in any sort of a form you can keep it, but over here what I wanted to show you that I have to pass my data as a final string only. Okay, this context and responses. Now what I did over here, see, I created a data frame of this data set, the data set which I loaded. Now see, context and responses, you will get the context and responses under this data frame. Okay, then what I did, I just saved it. So here I already shown you this file, right? So I can basically load the data from the Hugging Face. I can save it in my local, or else if I have a data in my local, the CSV data and all whatever, right, I can simply keep it over the Hugging Face. I can compatible into the, I can create a compatible data set, okay, with respect to this Hugging Face. Everything is possible, right? So see, I have converted into the JSON, I converted into the CSV, and both way it is possible. I hope this entire thing is clear. So this is just, guys, this is just a this is just a demonstration that how the instruction data look like, okay, and how to format it for the training. Now in my case, in this particular practical, I am going to use my own data set. Means I'm not going to be use any pre-built data set over here. I will be using this particular data. See, let me show you this CSV. So under the CSV, basically you will only get 5 to 6 rows. See how many rows is there. I just have 1, then 2, then 3, then 4 and 5. Okay, only 5 row. Now I have an instruction. Okay, this is the output of it. Then again instruction, output of it, instruction, output of it. Now instruction, now this is the input, and here you can see the output of it. Then instruction, here you can see the input, and this is the output, right? So guys, you can read this data, you can analyze this data. On top of this data only, we are going to perform the training. Okay, we are going to perform the fine tuning. Now guys, here what I shown you how the pre-built data set look like. It could be in any sort of a like there could be any sort of a column, right? And here what we are doing now, guys, we are going to be load our own data set. This data set actually I created by myself manually. Okay, you can create it using the LLM, you can take a help of any SME subject matter expertise, right? And you can generate this instruction data set. Now how ChatGPT has done that? So ChatGPT actually took the conversational data set. So conversational data set from the Reddit, from the Quora, from the GitHub, from the different places. Okay, but if you are doing for our domain specific problem statement, in that case we only have to create this data set. Okay, so I kept the data in both formats, CSV and JSON. In the real time also it could be in any sort of a format. Okay, now I'm going to be loaded in a CSV format. So let's load it and perform the formatting. Now guys, I loaded my CSV data over here with this function load data. Then I'm passing this parameter CSV, then I'm passing my file path. Okay, and then I'm writing split is equal to train. Means whatever data I'm going to be load over here, it will be a train one. Now inside the data set you can see we have 3 column: instruction, input and output. I can show you over here. This is my data set which I am using. Okay, now what I'll do, so after that guys, I will format it as a single string. As I told you, whatever data goes to the LLM, okay, it goes to as a single string, right? So let me run it, let me execute it. See, if you will see this formatting prompt, so we have an instruction, right? Instruction will come over here, then we have an input. Okay, the example will come over here, and then response. Okay, so example input will come over here, then response, then example output will come over here. Okay, so here guys, if I will run it, and after running it I can map it. Okay, after mapping it, see inside my data set I am having 4 column now: instruction, input, output and text. Now this particular column, this text column, we are going to use it for the training. Now let me show you the first row over here. You can see, so we have an instruction, then we have an input, and then we have corresponding responses. Okay, this is my responses. Now if you want to check with the CSV, now over here, see, check with the CSV. So this is my instruction. Okay, and then in the input I don't have anything, it will be blank. Then I have an output, right? So this first row is going to be combined. Likewise the second row will be combined, third row will be combined, fourth row will be combined. Means first row will be combined, and that will become my one string. I will pass it to the LLM for training. Likewise the second row, likewise the third row, fourth row, and so on and so forth. Okay, I hope you got it. So guys, this is my data. I have formatted my data. Okay, so first row, second row, third row, fourth row means whatever column we had over there, we just combine that and we'll be passing as a single string. And in that column, what we have our instruction and the responses of it. Now guys, see, this is the row which looks like this only. Over here you can see we don't have any sort of an input is none, and then we just have the response. If the input would be there, then instead of the none, the actual data for the input will be passed over here. Now I'm going to be initiate my tokenizer. Okay, now I'm going to be tokenize my data. So after tokenization, guys, see here I'm going to tokenize my data, means I'm passing my single example, my first row. Okay, now I'm taking the text from there, means this particular value. Okay, then I'm going to be truncate is equal to true. If max length basically if it is going to be exceed to the max length, then we are going to be truncated. Okay, otherwise we are going to be pad it if it is less than this 512, right? Now here is one more line, token labels is equal to token input IDs dot copy. So why I am doing it? So as I told you, the behavior of the model, so the behavior of the model is to predict the next token. Okay, so by using this line, basically I am telling to my model, so whatever data you will get, whatever text you will get, this entire row. Okay, so you have to train yourself in such a way that you are going to predict the next token. This all the thing I already discussed in my previous video. There also I have used the same technique. At some of the places I have seen, what I have seen, guys, so they are going to be mask the value till the responses. Okay, so till the responses they are going to be mask the value, means model will get to know, okay, so this till here basically I have an instruction, I have a question, and after that my response is coming. So how I will mask the value till response, means this particular value I can put any special toggle, like let's say I can put -100 over here. So here to here whatever token is going to be create, so for those token all the value will be -100 and the actual token will be assigned from here itself. Okay, actual token will be assigned from here itself. So this kind of technique also I have seen, right? So just to teach the responses to the model, we take this kind of we basically go ahead with this kind of technique also, right? But yeah, this is very effective, means we can entirely copy this input ID to the labels. What does it mean? Means I'm not going to be mask anything. Model from this particular text, model will learn how to predict the next token, right? So here is the all the thing is done. Now what I'm doing, guys, I'm going to be I'm going to be basically load the model as a Lora model. So from the PEFT I have used this Lora config, then get PEFT model, then task type. Now here whatever basically parameter I have used, you can see the description of it. So task type means it's a causal LM, means the next value prediction, next token prediction. Now here R is representing to the rank, so this could be the rank. Okay, control tenable parameter size. Now here Lora alpha, it's a scaling factor, so the value will be between this one. So balance adaptation strength. Now Lora dropout, so dropout probability 0.5, so it's a regularization value. Target module, which layer to tune, so I want to tune this query and the value. Trade-off between cost and quality, means you can select the other layer also. We have a key query value, right? So you can select the different layer which is remaining, the next one. Okay, then biases fine-tuning none, keep simple. Okay, so over here guys, we are going to be mention this parameter, but under this particular class Lora config, you will find out so many parameter. So maybe after discussing the mathematics of this Lora, we can talk about it, right? So here is my Lora configuration, guys. Now what I will do, I'll write get PEFT model. So here I will pass my non-instructional model, which I trained in my previous video, and here I am passing my Lora configuration. Okay, now I will be getting my Lora model. See here I got the Lora model. Now what I'm doing, I'm going to be define my training argument. So tiny llama instruction, here I will be getting my instruction model. For 3 number of epoch I'm going to be train it. Okay, per device train batch size, means how many batch in how many batch we are passing a data. Gradient accumulation step, so at what all step we are going to be calculate the gradient. Learning rate regarding the optimizer, it's a precision value. Logging step, at which step we are going to be log the value. Save total limit. Okay, now repeat report to none, means we are not going to be capture any sort of a matrices anywhere on any platform. So this is my all the argument, guys. Now what I'll do, I'll call the train method. To the train method I'll pass my model, I'll pass my argument, I'll pass my tokenization, right? Now my trainer is ready. Now what I'll do, I'll call this train. Okay, so here guys, see my model is getting trained on top of this data set. Now my model got trained. Now here actually you will get the model. See tiny llama instruction, this is my model. Okay, and under this you can see I have a checkpoint 3, and see my model got saved over here, adapter model dot save tensor, right? Now let me execute it. See, this is a model path. Now after that, what I can do, I can load my instruction model. Now here guys, see, this is my instruction model. Now I can give this kind of question to my model, explain the mechanism of the action of metformin, right? So earlier guys, I was not maybe I cannot give this kind of question to my model. It will definitely hallucinate. Okay, we'll compare that, don't worry. But guys, now after the instruction fine tuning, we can give this kind of question where, see, my data set is very small. I just train it for very simple epoch. Okay, my model is also very small one, so it might not predict correctly. But if you are doing it on a full scale with a good model, with a good data set, with a huge data set, okay, that definitely this technique will work. So here is my prompt. Now what I'll do, I'll tokenize the prompt, I'll pass it over here, means I'll pass all the tokens over here. Okay, now let me take the output. So here guys, you can see the output. So what output is generating? Clinical trials demonstrate that combine atrovestine with azitimb is a safe and effective for treatment of the hypercholesterol. Okay, so guys, here I ask, why explain the mechanism of the action of the metformin. So see, it is going to be explain everything, right? So it is going to be explain everything in the normal human tone. Okay, now over here guys, you can see, so this is all the data which I have. Now guys, I load the CSV data. You can load the data in the form of JSON also. Okay, and this is the pre-built data set which I took from the Hugging Face, means I shown you how to load it from the Hugging Face, and even I shown you how you can save it, and after saving it, anytime you can load it. Okay, or else if you will get the data in CSV and JSON, then from there you can easily load everything I have shown over here. Now I hope guys this thing is clear. Now let me show you one more thing. I was telling you that basically before the responses, okay, we can mask the value so that model can easily understand my response is getting started from here. So I took one code over here. Let me show you. So see what is happening over here. See, we are taking a data set. Okay, we are loading a data set, we are formatting a data set. After that, we are passing it to the tokenizer. Okay, the tokenization and all, everything is done. See, here basically I'm going to be initialize my tokenizer. Now see, I'm getting my text. Okay, now after that guys, see, I'm getting my input IDs, means my tokens. Now here I am writing response marker. So this is my response marker. Now wherever I will find out this response, or from wherever the response is going to be, start response, answer, whatever you can say. Now over here what I'm doing, so I'm going to be mark it. Okay, I'm going to be mark it with this. See, till the response, actually I'm going to be marked with this -100. Okay, so till the response, actually I'm going to be mark it with -100 with this special token, and after that the normal token would be there. So what does it mean? The mean is very simple. See, here I have written clone labels and mask out everything before responses. So the meaning is very simple. My model will be able to discriminate between the instruction as well as the responses. It will get to know, okay, till here means this is a special token, means this is my input, or like my instruction, and after that my actual response is getting started. Okay, so both training you can do, you can try out with this one as well as the previous one. Okay, you can check which one is giving you the effective result. According to me, the previous one is a good one, because here there actually my model is learning onto the my model is iterating onto the entire string. Okay, the entire row, right? Text, the instruction, input, and this responses. Okay, now here till response we are masking, and after that only we are allowing to model to learn through some tokens, right? So yes, I have like written this logic over here. You can go through with it. I have seen in many like places people are following that, so that's why I've given you this particular like solution as well. Okay, you can try it. Here is the entire code. Now guys, so I kept some question. Okay, and what I'm doing over here, I'm going to be check with my non-instruction and the instruction model what is going to be the answer, right? So I have both model, instruction and the non-instruction. So see, this is my question. Now what I'm doing, I'm iterating over the questions. Okay, now I'm tokenizing it, and after tokenizing it guys, I'm passing to the non-instructional model. I'm generating output and then printing the output. Now here what I'm doing, I'm going to be load the tokenization model. Sorry, I'm going to be load the tokenizer, then I'm loading the instruction model. Okay, and then I'm going to be perform the then I'm going to be generate the answer with the instruction based model. Okay, so here I'm going to be generate the answer with the non-instruction, here I'm going to be generate the answer with the instruction. So you will be able to understand. Okay, so if I'm asking this kind of question like explain this, summarize this, what is this, what is that, so instruction model will be able to perform good compared to the non-instructional model. So that's why guys, instruction fine tuning is required. See, my data set is very small, my model is also very small, so it might not give the correct answer. But if you are doing it really, first teach your model on your domain specific data set, on your PDF text and all, and later on perform some instruction tuning. It will work well, guys. It is proven technique. Okay, ChatGPT also did the same thing, right? First they have trained the entire data, first they have trained on the entire internet data, the self-supervised learning, and then after that they have trained it on a question answering task from the Reddit, from the Hugging Face, sorry, from the like different forum like GitHub, Stack Overflow and all, right? So let's run it and let's see what is going to be answer. So here it can predict it. See, the answer, explain the mechanism of metformin. So it is saying explain the metformin is drug. Fine. Now here, okay, expect output, test case. Okay. Now here it is saying summarize how mRNA. So guys, it is predicting something, right? Some garbage thing. Okay, you can try out from your end, you can check, right? You can take some more data and then basically again you can retrain and check that out, right? I took the very specific question, just 4 to 5 row, guys. With respect to LLM is nothing. Just take some good data set, retrain your model, okay, on the instruction data set and check. Okay, means first take the base model, check with the non-instructional data, means some PDF and all, train it, and then ask the question, and then again do one thing, create some instruction data, give your model, so model will learn how to follow this prompt and all, and then again ask the question to your model and check, okay, in which way it is performing well, in the instruction way or in the non-instruction way, right? So fine, thank you guys. I'll see you in the next video where I'll discuss about the DPO techniques and all. Thank you.